Hello everyone and welcome to microcasting. We're just going to be doing some microcasting weather explained here. We did a weather explained series before with the old graphics and stuff, and we've been doing quite a bit related to explaining weather to all of you, just so that way maybe you can better understand some concepts if you're interested in that. Well, now this is going to be a far more structured thing. We're now cutting off everything else, all those other weather explained videos, and we're starting a brand new season of it. This is season 2. Episode 1. You're going to be seeing these weekly. Every Sunday, you'll be seeing a weather explained video coming out that will be regarding some sort of weather topic. Now, this is going to be on both the St. Louis channel and the Tropical channel this time around, and it will be for the first few as we go over some basic concepts and things of that nature. But as we do move forward, we will be branching off into the severe weather and winter weather realms, as well as the tropical realms on their associated channels. So, look forward to that. Well, let's get started. Here are the basics. So, as you know, we see clouds all the time, and this is going to be something that we have to learn a lot about to understand a lot of the weather that I'll be explaining later. This chart from NOAA is a fantastic chart to show you basically every single possible kind of cloud that you can see here. But as you can see, yeah, we see clouds all the time. You may be surprised by just how many different clouds there are about the atmosphere. You know, a lot of us don't pay attention. You can see just on this graphic how many different kinds of clouds there are. There are tons of them. Clouds can vary drastically in appearance from cloud to cloud, as you can see, and some bloom into tall, puffy clouds, such as your cumulonimbus. Your nimbostratus even do this. But you also have your other clouds that are some that are thin and pretty flat. Your cirrus clouds tend to do this, and even your cirrostratus are fairly flat. So that's the particular stuff there as well. So clouds also have an influence. They can tell you a lot about the weather that's approaching. Your cirrus clouds, if you're seeing cirrus clouds and nothing else, there's some moisture present. But normally you're not going to be seeing too much in the way of storms. If you start to see some clouds slightly lower, if you start to see stratus clouds, that can mean a few things. You could get some rain associated with stratus clouds, but you're probably not going to get something overly severe. If you start seeing cumulus clouds and popcorn clouds, then you may see something, especially if they start to tower. Then they become cumulonimbus, and these are the kinds of clouds that form thunderstorms. These thunderstorms are the ones that produce your strong winds, your large hail, your tornadoes, and they even are a part of hurricanes, those cumulonimbus clouds. Clouds can trap warmth in the sky and save you from the heat of the day. They can also, while trapping that heat, take that energy and use it. But clouds are crucial for, storms. If you have lots of clouds in the morning, your heat doesn't make it to the surface, then you're not going to have as much energy from the surface moving into storms later in the day. And obviously, if you don't have energy coming from the surface, right, then you're not going to be able to get your tornadoes because your tornadoes need to have energy sustaining them directly to the surface. So that's something that clouds can do as well. The most incredible thing, in my opinion, about clouds is that the winds are very powerful in the atmosphere. And so what that means is that while the winds could be calm, 5 to 10 miles per hour where you are, just about 10,000 feet above you, winds could be screaming at over 100 miles an hour, moving clouds extremely quickly. You know what else is actually really interesting? I just found this out. Clouds are actually on other planets too. This I guess would sound relatively obvious, but I didn't know it was really observed or kept track of that much until today. So that was something really interesting to learn. All right, moving on. This is the second and final slide for the basics. So the weather that we experience every day is a result of what's happening above us. There's always air moving around, there's heat ready to be established, there's always an imbalance in the atmosphere. So let's address that. There are a lot of different components to weather, and now that we have a better understanding of how clouds work, now we need to know how all these systems move and what causes them, what causes this rain. So, in the most basic terms, the H's that you see on the map are your high pressure systems. High pressure systems rotate clockwise and outward. These normally bring in cooler conditions and drier conditions, and normally shove out of the way your low pressure systems. Low pressure systems are precisely the opposite. They happen to move counterclockwise and inward. That's how they rotate. So precisely the opposite, and as you would have guessed, precisely the opposite conditions as well. You're going to be getting rainy conditions, humid conditions. So that's how that's going to work for you. Going over fronts, you can see the warm front. That's your red line. That's going through Missouri, Illinois, Indiana, that particular area. It's one of the boundaries between your green area south of the warm front and your blue area north of the warm front. This is the boundary between your cool and dry air and your warm and moist air. And along this boundary, you can get storms to form. The most potent boundary, though, for storms to form is your cold front. That's the blue line that you see there with the little spikes at the end of it, if you will, those triangles. So you have basically this front moving in, and it's going to cause storms. So that's a big thing from that. And you also have a dry line. Now that's that brownish kind of colored line there with the circles, the semicircles that aren't filled in. So that is what's mostly associated with things such as tornadoes. You have a very fine line between where you have the moist air and the dry air. So while your temperature may not be in huge contrast, you're definitely going to have enough of a contrast in your moisture to trigger some storms where it is supposed to become equal. So let's talk about some more upper level things. So your polar jet stream, that's something that's extremely important. That's really important because your polar jet stream and your subtropical jet stream determine where exactly your systems go. So that's going to be something we'll talk about in the future, but that's definitely an important term to hold. So that's really what we've been talking about for today. Alright, well, with that being said, this is the end of the Weather Explained video, and I thank you very much for watching. If you have any questions, comments, concerns, put those in the comments and I'll answer them as soon as I can. If you'd like an additional video in more detail on any of the concepts I've explained today, I'll let you know if they're planned in the future, or if you leave it in the comments and it wasn't planned, then please feel free to let me know, and I'll be more than glad to make a video added on to the season. Alright, well, now that we've said all that, you can follow us on Facebook at Microcasting St. Louis, follow us on Twitter at Microcasting STL, or follow us on Instagram at Microcasting St. Louis. If you're on the tropical end of things, that's Microcasting Tropical on Facebook, Microcasting TRO on Twitter, and Microcasting Tropical on Instagram. You can also join us on Discord with the link in the description, and that's going to be a fantastic way for you to interact with the weather community over there. And also, if you want to become a part of the Microcasting team, help out with production, and also be able to have access to a whole slew of weather graphics and experimental products we're testing behind the scenes, feel free to join that. Alright, and with that being said, thank you all so much for watching. Like the video if you liked it. If you didn't like it, you know where that button is. You can subscribe and hit the bell to turn on notifications so you never miss a new video. Alright guys, this is Microcasting, signing out.